We're going to continue working with graphs of linear equations. We're going to review how to graph them, and we're going to examine several characteristics of each graph. You will need a piece of graph paper to use as you work through the presentation. The first equation that I want to graph is in standard form. 2y minus 5x equals 10. I'm going to rewrite the equation into function form. The first move will be to add 5x to both sides. This yields 2y equals 10 plus 5x. The final step will be to divide both sides by 2. Since the right side has two terms, I must divide both of those terms by 2 as well. This yields the equation in function form as y equals 5 plus 5 over 2 times x. The next step is to build an xy chart. This will give me the ordered pairs that I need to graph the equation. The left side is going to contain the x variables, or the independent values, and the right side will contain the corresponding y's, or the outputs of the function. The first input that I want to use is a -4. So when x is a -4, I want to figure out what the y value is. I plug that into my equation. So when x is a -4, follow the order of operations and discover that the y value would be an opposite 5. The next x value that I want to use today is 0. So when x is a 0, I'm going to plug that into my function to figure out the corresponding y value. Following the order of operations, multiply 5 halves times 2 and get 0. So when x is 0, y would be a 5. Now I only need 2 points to define a line, so I'm going to go ahead and plot my 2 points. X is a -4 and y is a -5. The second point is at 0, 5. X is 0, y is a 5. The final step will be to draw a line through those 2 points. Now, since there aren't any restrictions on the domain and range, I want to go ahead and add arrows on both ends, indicating that the line doesn't stop and that we can continue putting in x and y values for as long as we need to. Now, the two characteristics that I want to look at today are as follows. This point right here, or this location, is referred to as the y-intercept. Now, this is the point where the line crosses the y-axis. The second characteristic or point that I want to look at today is this one right here, and that's at -2, 0. Now, we did not find that when we built our table, but when we drew our graph, we found that point by just simply drawing the line through that location. That point is called the x-intercept, and that's the point where the line crosses the x-axis. Let's take a look at this example. We're asked to find the x and y-intercepts for the equation in standard form. So our first move will be to rewrite the equation into function form. We'll subtract 1x from both sides to isolate the y. So the equation in function form is y equals 4 minus 1x. The next step will be to build the data table. The first x value that I want to use today is a 2. I'm going to plug it into my equation to figure out the corresponding y value. Following the order of operations, when x is 2, y will be a positive 2, excuse me. Go ahead and fix that before we move on. The next x value that I want to use tonight is 0. Following the order of operations, I'm going to plug that value into my expression and simplify it. So 1 times our x value of 0. This term is eliminated. So when x is 0, y is a 4. Once again, I only need 2 points to define the line, so I'm going to go ahead and plot those 2 points. X is 2, y is 2. Plot that location. X is 0, y is a 4. And we'll plot that location. We'll draw a line through those 2 points. And once again, since there aren't any restrictions on this problem, we're going to go ahead and put arrows on the end indicating that the domain and range are unrestricted. And then we're going to find the x and y intercepts. Now we will recall that the x-intercept is the point where the line crosses the x-axis. So in that location would be found right here. So the coordinates of the x-intercept would be 4, 0. The other location we're interested in is known as the y-intercept. And that's at this point here, and those coordinates would be 0, 4. Let's look at one more example. Let's find the x and y-intercept for this equation, y equals -2. Now when we set up our data table for this one, we already have a restriction on the range. The restriction on the range is that a y value has to be a -2. So we go ahead and fill those points in, and then select any x value that we choose. So x could be 0, or x could be a 1. Go ahead and plot those 2 points. So when x is 1, y is a -2. When x is 0, y is a -2. Likewise, if we chose an x value of 2, y would still be a -2. So we see we're going to get a horizontal line, and there aren't any restrictions on the domain, so this line is going to continue to the right and to the left indefinitely. To indicate that, we're going to draw a set of arrows on both ends. Now the question is, what is the x-intercept of this equation? Well, the line doesn't cross the x-axis at any point. So in this situation, there is not an x-intercept. There is, however, a y-intercept. And that location is right here. The coordinates of the y-intercept would be at 0, 2. So let's review. The 2 characteristics that we talked about today are first, the y-intercept. The y-intercept is the point where the line crosses the y-axis. The second characteristic that we examined today was the x-intercept. And the x-intercept is the point where the line crosses the x-axis. You will need to bring these notes tomorrow, and we will continue our lesson and our discussion in class.